Hello, today we're going to learn how to add and subtract fractions. In these two problems here, take a close look at the denominators. I notice here that we have 25 thirds and 13 thirds. Yes, these are improper fractions, but I notice that these denominators are exactly the same. When your denominator is the same, you can simply add or subtract your numerators. Now, what you can do here is look at 25 and 13. They both have a denominator of 3, so we can simply do 25 minus 13. Now, I notice those numbers are a little large. Some of you might not need to write this out on the side, and some of you might want to confirm that you get the correct numerator. So I'm going to write this on the side, confirming that I have 12 as my numerator. Now notice my denominators were 3 and we're working with thirds. So my answer is going to remain in thirds. Now 12 thirds, you can choose to leave that as an improper fraction, or you might recognize that 12 divided by 3 is also 4. So here you have 12 thirds is equivalent to 4. Both answers are correct, but when we can actually get a whole number, you're welcome to continue and make the answer, turn the answer into a whole number of 4. Notice again, 12 thirds is equivalent to 4. Now in this problem here we have twelfths. I notice we have two improper fractions, but both my denominators are 12. Therefore, you can simply add or subtract my numerators. Now it's very important that you always take a close look at the operation given to you. In this problem we had subtraction, but in this problem we have addition. So what I'm going to do again is write out on the side my numerators. 53 plus 20. Now when I add these two numbers together, I get my new numerator of 73. And my denominator continues across because we're continuing to work with twelfths, and my answer's in twelfths as well. So we have 73 twelfths as my answer. This is an improper fraction. You are welcome to leave it as an improper fraction. If I take a look and I look at 73 divided by 12, I do not get a whole number. You would in fact can turn this into a mixed number if you would like, but you're welcome to leave it as 73 twelfths. Now we have another problem. This time we have tenths and we have hundredths. Unlike my other two problems I just completed, I notice here that my denominators are not the same. Before I add or subtract, I need to do something to change my denominator so they are the same. Now I notice I have 10 here and I have 100 here. I'm going to write 3/10 on the side. And I do know that 10 times 10 is 100. So I can change 3/10 to a new fraction. Now I notice that 10 times 10 is 100, and if I multiply my denominator by 10, if I multiply my denominator by 10, I do the same to my numerator. So 3 times 10 is 30. So notice now I can rewrite 3/10 to 30 hundredths because 3/10 and 30 hundredths are equivalent. So I'm going to change this 3 to a 30 and this 10 to a 100. Now I can simply add 30 plus 26, which happens to be 56. And my denominator remains 100ths, giving me a sum of 56 hundredths as my final answer. Notice before I add or subtract, it's very important that you change your denominators so they are exactly the same. In this problem here, again, I have 3/10 plus 5 hundredths. Now, in this situation, I have 10 and 100 as my denominator. I'm going to change 3/10 to 30 hundredths because I proved in my previous problem that 3/10 and 30 hundredths were equivalent. So now all I need to do is add my numerators. So I have 30 plus 5, which is 35. And my denominator of 100 is going to remain the same in my answer as well, giving me an answer of 35 hundredths, which is the sum of 3/10 plus 5 hundredths, or you could say the sum of 30 hundredths plus 5 hundredths. In this problem here, I have 7/10 plus 30 hundredths. But I do know that 7/10, I think I can change this fraction that will have a new denominator of 100. So let's find an equivalent fraction. Let's see, 10 times 10 is 100. So if I multiply my denominator by 10, I do the same to my numerator. So 7 times 10 is 70. So now all I'm going to do here is change this to 70 hundredths. Now I can simply add my numerators. 70 plus 30 is 100. And I'm going to stick with my same denominator of 100. Now you can leave 100 100ths as your answer if you would like, but I'm hoping that you recognize that 100 divided by 100 is 1 whole, and you're welcome to represent your answer as 1 whole. Notice when you have the same numerator and the same denominator, that is equivalent to 1. In this problem here, we have 3 fractions, but we're going to follow the exact same methods. Now here I have 1/10, 36 hundredths, and 2/10. My goal is to change all these denominators so they all are 100 before I start adding. I know that 1/10 is equivalent to 10 hundredths, and I found that by multiplying my numerator and denominator both by 10. I know that 2/10 is equivalent to 20 hundredths, and I find that by multiplying my numerator and denominator both by 10. So now here I'm going to change this to 10 hundredths and this to 20 hundredths. Now I know my answer will also have the same denominator as 100, but I need to find my numerator. So what I'm going to do on the side is write 10 plus 36 plus 20. When I add these 3 numbers together, I get a sum of 66. So now that's my new numerator, giving me a final answer of 66 100ths. Now notice before I added anything, I always look at my denominators. If they are already the same denominator, you can simply add or subtract your numerators. If they are different denominators, your goal is to change the fractions by using equivalent fractions to help you do this, so you can change them so they have the same denominators. Once you make them the same denominators, you can simply add or subtract. Notice I rewrote this stuff on scrap paper. You may need scrap paper when you're completing today's activities so you can successfully solve each of these problems. As always, feel free to refer back to this video on adding and subtraction at any time on my YouTube channel.